Hello, this is Carlos Martinez, student at California Intercontinental University, Business Research Methodology and Quantitative Statistics Course 605. This is a Unit 6 presentation conducting a linear regression using PSPP, Dr. Nigel Basta, instructor. Our agenda is first an introduction of regression. We will conduct 3 simple regression tests using PSPP. We'll state the null and alternative hypothesis and state the rejection rule for each. We'll test, the test process will be to state the hypothesis, create a plan for analyzing the data, and interpret the results. Finally, we'll post takeaways from our findings and from the presentation, and we will invite questions. A linear regression was conducted to determine a relationship, if any, between 2 variables. The data set used in our regression test was generated from 150 participants using SurveyMonkey survey. The survey asked questions regarding personal financial data such as savings, income, stocks. R-squared is a term that we will be using. It's a statistical measure of how close the data are to the fitted regression line. We've got 3 tests. The first regression test, the question is, can we predict an individual's debt by knowing the individual's income? Second regression test, can we predict an individual's savings by knowing the individual's income? And third regression test, can we predict the individual's value of their stock portfolio by knowing their savings? The rejection rule will be as follows. We reject the null when P is less than alpha, where alpha is 0.05. Our confirmation rule is 0 is not within the 95% confidence interval. The terms that we will be using, linear regression. It calculates an equation that assesses the distance between all of the data points and the fitted line. R-squared, which is a statistical measure of how close the data are to the fitted regression line. Beta coefficient, the estimates resulting from an analysis performed on variables that have been standardized so that they have variances of 1. Confidence level. The confidence level is a probability estimate of how much reliance can be placed on the findings. Our commonly accepted level in social science research is 95%. Regression analysis used in a situation where one or more independent variables are hypothesized to affect a matrix dependent variable. The first hypothesis test. The question is, can we predict an individual's debt by knowing the individual's income? Our dependent variable is the debt and our independent variable is the income. The null regression coefficient, beta, is 0. The alternative regression coefficient is non-zero. So here a simple linear regression was conducted, as you can see on the left side. No significant regression was found. Our beta coefficient is 0.05. R squared, which is a coefficient of determination value, is 0.00. Our P is 0.535. Well, here we failed to reject the null. And as we conclude that there's no significance or significant relationship between an individual's debt and their income. Here the question is, can we predict an individual's savings by knowing their income? Dependent variable is savings, an independent variable is income. Our regression coefficient beta null is 0, and the regression coefficient beta for the alternative is non-zero. So a simple linear regression was conducted, as you can see to the left. Now this test resulted in a significant regression. Our beta coefficient 0.91, R squared, or coefficient of determination value 0.82. Our p-value is 0. The coefficient interval 95%. That means that our data, our sample data, lies somewhere between 0.09 and 0.11. Now, this supports our prediction because the variable does not contain a 0. Therefore, the savings is predicted to decrease as income increases, and we reject the null hypothesis. Our third hypothesis test. The question is, can we predict an individual's value of their stock portfolio by knowing their savings? The dependent variable are stocks, and the independent variable savings. Our regression test, as you can see to the left, was conducted, a simple linear regression, and it resulted in a significant regression. Our beta coefficient here, 0.28, our R squared, or coefficient of determination value, 0.07, our p-value is 0. The coefficient interval of 95%, here, this is telling us that the sample data lies between 0.07 and 0.25. This supports our prediction also because it does not contain 0. So our conclusion here, stocks decrease as savings increase. Our annotated bibliography. The first one was regression analysis. How do I interpret R squared and assets and assess the goodness of fit? This was great because the mini blog series is very helpful. It is something that I will be using in the future, and as a foundation, it's something that will be used throughout my study. The mini blog is open source computer software that we use as students. Now, it is a privately owned company located in State College, Pennsylvania. The mini blog serves students, professionals, institutions, and professors and instructors. They do offer fee services for those institutions and others that want to expand their capabilities and use the software for other applications. What I like about it is it's supported by scholars in various fields, and just about all of them are related to statistical research. The design is familiar because it's utilizing worksheets. The menus and the dialogues are very user-friendly. The analytical tools are relatively easy for use, even for the first timer. And they provide it provides very clear and concise steps that were progressive. The second are the videos by Stephen Hess. Now, I reference one video because this was the first one that introduced me to visual hypothesis testing. The lectures by Dr. Hess were clear, provided a step-by-step process for my conceptual understanding. Now, this provides a foundation for learning quantitative statistics, and I'm sure I will be utilizing a series of his video lectures as well. This was instrumental in performing my assignments from week to week. The format that he uses is a format that I probably will continue to use, and it represents a foundation for future assignments and future research. The third is the video lecture series by Brandon Fultz. Now, I was introduced to simple linear regression with his first video, but he has a series. I love how a number of videos are 22 plus minutes, step by step, as if the person is a beginner, new to the field. His mission, as he states it, is to create and design learning and teaching platforms for publishers, college instructors, and students. Currently, he's a senior learning designer for Cengage Learning. Cengage is a publisher that I use in my own community college courses. He's called upon by instructors, institutions, employers to develop ways to reach students, to engage students, and to retain students. And he's called upon to provide research for professionals. The first video, simple linear regression, was foundational for me. I found it to be very good. I found his step-by-step approach very helpful because he goes from very simple and he builds upon that. The takeaways. The R-squared is a good tool to measure how well your linear model fits a set of observations. A simple linear regression allows us to statistically display the relationship between two or more variables. And the goal in creating a linear model is to minimize the sum squares of the residuals. Using PSPP makes the testing easier. No need to utilize manual calculations with a calculator. I'm sure there are much more applications, but very user-friendly for what we've done so far. And I've listed the references here. Thank you very much for watching. If you have questions, there's my email address. Please contact me.